The next step is we have Smart Frac run. So we read the pin report. Part builder found 324 pins. Now Smart Frac is the tool here it has FPGA intelligence. It's going to read all the pins in the pin report, and it's going to break it up into I/O banks for us. So it's called Smart Frac because it fractures the symbol for us. And so what we'll do is we'll double click, we'll read that, and what happens is here's the report we get. So part builder Smart Frac is examining the pin database. It auto-detected 9 generic I/O banks for the PLD device. It was 1A, 1B, 2, 3, 4, 5, 6, 7, 8. Okay. What it did is it created this SDL from template.sdl file for us. This is the symbol description language file that's going to describe how we want the parts built. So Smart Frac does that for us. And if we open the SDL editor, we can see what it created. So it puts a comment in the top that it found these generic I/O banks. And what it does is it builds one symbol for each one of these banks. So we can see it found 1A, 1B, 2 to 8. So there's 1A, 1B, 2, and if we slide down, it's going to go to 8. And then what it does is it finds all the power pins and it distributes them for us in a nice looking symbol. So with this, we can go build the symbols already. If we look around, sometimes in an Altera FPGA, there'll be some parts that are I/O pins that we don't know what they are, and there'll be a choose side assigned to them. But in this case, there's not a lot of, in the CPLD case, there's not a lot of extra configuration pins. Since we have no choose sides in here, it means that Part Builder and Smart Frac were able to create this all and get ready to build the symbol for us automatically. Let's take a quick peek at this bank. So it built a symbol called FPGA Bank IO, and here the symbol ends. On the left, we're going to put all the VCC IO 1A pins. And here on the right, we're going to put all the I/O pins that end in 1A. Then we're going to start another symbol for FPGA Bank's IO 1B. And here on the left, we're going to put the VCC IO B pins. And on the right, we'll put all the IO 1B pins. So you can see this is going to make a bunch of symbols. It's going to make 1, 2, up to 7, 8. So that'll be 9, and then a power pin symbol. So let's hit run and build symbols from here. And we can see it ran right through and it built the symbols for us. Now let's go take a peek at what we wanted to do, what we want to see. And we're going to look here and we're going to take a look. So here's the first one it built. It put the VCC IO on the left and it put the 1A pins on there. So it built 10 symbols for us. And now we can walk through them. There's the VCC IO B and the 1B pins. And then here's bank 2, bank 3, bank 4, bank 5, bank 6, bank 7, and bank 8, and then we're going to see the power pins. And the way it works with the power pins is it finds the biggest set of pins and it puts it in one spot, and then it tries to fill in on the other side all the power pins that are left. So it found all the ground pins and it placed them on the right. Then it found the VCC1 pins, the VCC-A3, the NC pin, the no connects, the VCC-A pins, and the VCC-A4. Now we can move this around any way we want, but for now let's close this out and say we're done, and we'll look at moving around in the next video.